Hello friends, welcome back to Webronaq. In this video we're going to write a small C++ program that calculates the area of a circle. Now on the surface this looks like a basic math exercise, but underneath there's something genuinely interesting happening. We're taking a continuous, real-world geometric quantity, the area swept out by a curve, and squeezing it into a finite chunk of memory that a processor can work with. That's the quiet magic of every numerical program you'll ever write. The formula itself is the one you already know. Area equals pi times the radius squared. Pi is irrational, meaning its decimal expansion never ends and never repeats, so the moment we store it in a computer, we're already making an approximation. Keep that in the back of your mind. It'll matter later when we pick the right data type. Alright, let's set up the first piece of the program. Alright, every C++ program starts with a couple of setup lines, and these two are doing real work even though they look like boilerplate. The first line, #include iostream, is pulling in the input-output stream library. Think of it like loading a toolbox before you start a job. Without this line, the compiler has no idea what cout or cin even mean. The iostream header is what gives us the ability to print to the screen and read from the keyboard. The second line, using namespace std, is a small convenience. Every name in the standard library, cout, cin, string, vector, all of it, lives inside a namespace called std. Without this line, we'd have to write std::cout every single time. With it, the compiler knows where to look, and we can just write cout directly. It's the same idea as adding a folder to your system path, so you don't have to type the full address every time you run a command. Now with the setup done, we're ready to write the actual program logic. Now look at this. We have the main function, and inside it, we're declaring two variables, radius and area, both of type float. The int main part is the entry point. When you run a C++ program, the operating system looks for a function called main, and starts executing from there. Everything happens inside those curly braces. The int in front of main just means this function will eventually return an integer back to the operating system to signal whether things went well or not. Now the interesting choice here is float. We could have used int, but a circle's area is almost never going to be a clean whole number, because pi itself is irrational. Float gives us a decimal number, stored in roughly 4 bytes of memory using something called the floating point format. Underneath, the computer is storing the number as a sign bit, an exponent, and a mantissa. Basically scientific notation in binary. It's an approximation, but for a circle's area it's more than enough. When this line runs, the program carves out two small slots in memory, one labeled radius, one labeled area, and they sit there empty, waiting for values. We need to actually put a number into that radius slot. Here's where the program starts talking to the user. Two lines, two directions of data flow. The first line uses cout, which stands for character output. The two less than signs after it are called the insertion operator. They push whatever is on the right into the output stream. So this line is taking the text, enter radius, and sending it to the screen. Underneath, cout is connected to standard output, which the operating system has wired up to your terminal window. The second line uses cin, character input, with two greater than signs called the extraction operator. This one works in the opposite direction. It pulls whatever the user types from the keyboard buffer and stores it into the radius variable. The arrows literally point the way the data is moving, out to the screen, in from the keyboard. There's something elegant happening here. The cin operator is smart enough to look at the type of the variable on its right, and parse the keyboard input accordingly. Since radius is a float, it reads the typed characters and converts them into a floating point number before storing them. That conversion from a string of digits to a binary float is happening silently in the background every single time. Now that we have the radius sitting in memory, it's time to do the actual math. Alright, this is the heart of the program. One line of code, but a lot is happening underneath. We're computing area equals 3.1, 4 times radius. The formula for the area of a circle is pi times the radius squared, and here we're using 3.14 as a stand-in for pi. That's a deliberate approximation. Pi has infinitely many digits, but the processor can only hold a finite number of bits, so we have to truncate somewhere. 3.14 is rough but readable. For a more accurate program, you'd use a constant like m_pi from the cmath library, which gives you pi to about 15 decimal places. Now watch the order of operations. C++ evaluates this left to right because multiplication has equal precedence at each step. So if the radius is 5, the processor first computes radius times radius, which is 25. Then it multiplies that by 3.14, which gives 78.5. That final result is what gets stored into the area variable. Here's the interesting part. Each of those multiplications is happening in the floating point unit of your CPU, a dedicated piece of silicon designed specifically to multiply and add decimal numbers in hardware. What looks like a single line of code is actually 2 hardware-level floating-point operations executing in nanoseconds. Just need to show the result to the user. And here's the finish line. 2 more lines, and the program is complete. The first line uses cout again, but notice something. We're chaining 2 insertions on the same line. First, we push the string area equals into the output stream. Then immediately after, we push the value stored in the area variable. The cout object is designed to be chained like this, so you can keep adding pieces to the output without writing a new statement for each one. The result is a clean line on the screen that reads area equals 78.5. The second line, return 0, is the formal handshake between your program and the operating system. When main returns 0, it's signaling that the program finished successfully without any errors. If something had gone wrong, you'd return a non-zero number to indicate failure. That convention, 0 means success, non-zero means error, runs through Linux, Windows, and pretty much every shell script you'll ever write. It's why you can chain commands together with double ampersands, and have the next one only run if the previous one succeeded. The closing curly brace ends the main function, and at that point, the operating system reclaims the memory the program was using, and we're done. So in just a handful of lines, we've taken user input, performed a floating point calculation in hardware, and printed the result back to the screen. The full input, process, output cycle that sits underneath every piece of software you use. Alright, let's step back and look at the whole thing together. What you're seeing is a complete, working C++ program in just about a dozen lines. And if you trace it top to bottom, it follows the exact same pattern that every program, from a simple calculator to a video editor, follows underneath. Setup, declare, input, compute, output. At the top, we set up the environment by pulling in the iostream library and the standard namespace. Then we enter main, where we declare the 2 floating point variables that will hold our data. We ask the user for the radius, and read it from the keyboard. We compute the area using the formula. And finally, we send the result back to the screen, and return cleanly to the operating system. What's worth noticing is how much of what's actually happening is invisible. The keyboard input gets converted from characters into a binary float. The multiplications run on dedicated floating point hardware inside the CPU. The output gets converted back from a binary float into readable digits on your screen. All of that machinery, text to number, hardware math, number to text, is wrapped up in those 2 operators, cin and cout. That's the real beauty of a high-level language. You write the intent, the compiler and the hardware handle the rest. If you want to make this program more accurate, swap 3.14 for m_pi from the cmath header, and you'll instantly jump from 2 decimals of precision to about 15. Same logic, sharper result. That's the area of a circle in C++. Simple program, but every line of it is doing real work. That's a wrap on this one. If this video helped you understand what's actually happening when a C++ program does something as simple as calculating the area of a circle, hit that like button. It genuinely helps the channel reach more learners like you. Subscribe to Webronaq so you don't miss what's coming next. We've got more C++ tutorials, plus deeper dives into the math and hardware that sits underneath the code we write every day. And drop a comment below. Tell me what you'd like to see next. Maybe a program that handles more complex shapes, or a closer look at how floating point numbers actually work inside the processor. Your suggestions shape what gets made. Thanks for spending this time with me. See you in the next video.